Okay, so
Oh,
all we have today is the quiz. And there's 4 questions, but question 4 has an A, B, and C.
yeah, I found the quiz. It was just hiding.
Oh, yeah, it shouldn't be too
Yeah, I don't think so.
bad. Okay, so logarithm. Um,
I don't know the exact definition of it, but I know it
yeah,
cancels out an exponent kind of
right.
thing.
Can have different base numbers.
Yeah,
Um,
I'm gonna look it up quickly in the book. Number two is basically like that. It says like logarithms and exponential functions are inverse functions. What does that mean? It means that a log will get rid of an exponent, and an exponent will cancel out a log, kind of thing.
okay.
If that makes sense.
Yeah. Okay. Um, number 2 are inverse functions. Means that they're opposite.
Yeah, it's just kind of like that thing where it's like you plug in x for y and y for x. And
Okay.
okay.
Um, inverse of the function. So is this the one where we find like f to the -1?
Yeah.
Okay.
Okay. In the book, it says the definition is the inverse of the exponential functions are called logarithmic functions.
Okay. Hey, Ben.
Hey,
We're working on the group quiz right now.
okay.
Where are my calculators?
So where are you guys at? Number 3?
Yeah, we're working on number 3.
So what'd you do first on that one, Chris?
Well, first what I did was I subtracted 3 for both sides just to get the exponent by itself. And I took the log of both sides to get it out of that exponent. The log of x minus 3 to like the third is equal to y plus 4. And it's like subtract by 4, divide by 2. Yeah. What'd you do?
Log of x minus 3 to the third.
Yeah, because the way the log works is like it would take the thing on the left, it would be like the log, and so that smaller number would be the x minus 3 number that has the exponent, and like multiply it over there.
So when you move it over, it goes into the parentheses.
Yeah.
When you move the exponent over, I wasn't sure on that part.
Yeah.
So you get log x minus 3 parenthesis 3.
Yeah.
Okay.
Is equal to
2y.
y. Yeah.
Yeah. And then you just solve for y from there.
Yep.
So when you add the 4 over, or minus the 4 over, what does that change? It becomes log x
I don't think it changes everything.
minus.
You just add the
Yeah.
4 over because like that, even though the 3 is in parentheses, that's like it's attached to the log, so you have to do like that stuff first. The y.
Okay.
Does anybody have any questions or?
So what's the final answer look like? Log x minus 3,
Mhm.
3 in parentheses,
Uh,
and then plus 4.
-4.
-4.
And just all over 2.
Yeah, but then you can kind of simplify it out. So like you can divide the 4 by 2.
And bring it down to 2.
And so, yeah, so it's like the log will be under 2, will be divided by 2, but then it's just -2.
Okay. Log x minus 3, parentheses 3 minus 2, all over 2.
Well, it's not all not all
Minus
over
2
2.
hangs out on its own.
Yeah.
Interesting. Okay.
Okay. Yeah.
Okay, ready to move on to 4A. Okay.
This one's a little tricky.
Yeah. I haven't got very far into these either, so.
Yeah. Well, like I worked it out, and the way that I got the right answer is like you have to start on the outside of it.
Mm-hmm.
Like you start with the log of 4, and then just kind of do the whole exponent rules.
You say we use the product rule for this one? Or what did you say, the exponent rule?
Yeah, or whatever. Like how do they word it in the book? It's like y a to the x. So like it's the same as x is equal to the log of a.
What section is that in?
It's at the very beginning of like the section that has like the log. I think it's like 4.2 or something.
Early on.
Yeah, like the first section should be on exponents, and the second one's about logs. Did you find it, Ben, or?
No, I'm reading. You can go over it if we want. That'll probably be easier.
So it's yeah, it's the section, and it's like very first page definition of the logarithmic function.
Mm-hmm.
Again, like that orange box, like the whole y the parentheses x, and then if and only if, like the whole a to the y is equal to x.
Mm-hmm.
And so like basically what we're doing is the whole like the log one into the exponent one. So
Okay.
yeah, like I was confused about how to do it at first, but then I'm starting to get it where like the you take that smaller number, like a number like the log of a,
The base.
and then you take the base, and then the exponent is the equal sign.
Repeat
like
that. The exponent is what?
The opposite side of the equal. Move the thing in parentheses to that spot.
Oh, so it'd be the negative. So is it saying on this number 4 on the quiz, it's log 4 negative x? So it become
So on this one, what it'll do is like to get rid of that log of 4,
mhm.
to 4 to the 0 power to the log of 3 parentheses log of 2. If that makes sense.
4 to the 0 power is equal to the log of 3.
So it's like what we're
It does-
doing is
So do you write
all right,
0 for 0 power?
yeah, which is like 4 to the 0 power is 1, basically. And it's like
Hmm. No, I need to do
And
some.
we,
I need to do some more reading. For some reason, I'm just not connecting on this one. I don't know why.
maybe it'd be easier if we did like a
So do you just leave it like that, or do you have to do it for like all of the different log bases?
Yeah, you have to like go through and do it again and do it again
Okay,
and solve for x.
gotcha.
You following him, Rachel?
Yeah.
Good.
Would it be easier if we had like a example question for you, Ben?
Possibly you got one in there I could look at.
In the book, I'm not sure where it would be. I just kind of made one up on the spot.
That's good. What do you got?
And so like first well, let's just do the exponent. So like 4 squared.
Four squared.
So what's 4 squared?
16.
Yeah.
Or
And the way the log works is it counteracts the exponent. And so
okay.
so
So the
now
second power.
so the way it works is that you would do the log of you would take the 4 because that's the base,
Uh-huh.
and then you take what it would become, like the
16.
16.
Uh-huh.
And go ahead. Can you plug that into your calculator?
Yeah. So 4 minus 16 or
The log of 4
oh,
parentheses
okay, log.
16.
Did you get 8 for that last one, Chris?
Yeah.
So the log of 4.
Parentheses 16. Like,
Do you have a grapher? Oh no, you have your okay, here we go. So the log of 4,
Yeah.
parenthesis 16.
yeah.
You close
On your calculator,
Uh-huh.
on your calculator, do you have like a button that lets you change the base of the log of 4? I mean, change the base of the log.
Probably it's a grapher if I know how to use it.
It's like on the calculator I normally use, I don't
Mhm.
have it, and the way that I looked up online how to do it is you take the log of like the parentheses number
Mhm.
divided by the log of the base number.
Okay, so is the log number 16?
The
Or which one
what?
would be the base in your scenario?
The base in the scenario is the 4.
Okay. So you punch in log of 4 divided by
No, you do the log of 16 because like you take
okay.
the one in parentheses first.
Okay. The log of 4 is 16. I
And if
think
we
I'm
did it
following.
right, it should come out to be 2.
So the log of 16. So what were you saying to do it manually? Divide it by,
divided by the log of 4.
okay. Log of 16 divided by the log of 4.
And it should come out to 2.
Came out to 2. Yep.
Yeah. So can you kind of see the correlation between like the 4 squared equals 16,
Mm-hmm.
the log?
Yeah, so the log is the base squared.
Not always.
Not always.
So let's see. Let me think of another one. Ready. So we could do the log of 5 parentheses 125. What would that equal?
So just log of 5 parentheses 125.
Yeah.
I got like an 87.37.
We'll do the whole
The same formula.
again, like,
Log of
yeah.
5 divided by the log of 125.
other way around.
Point 333
Other way around. Do the log of 125 divided by
by the log.
yeah.
Three.
Yeah. So it's like if it's the log of like if it's giving the log, then on the other side of that equal sign will be what power the base is. If that makes sense.
Oh, okay.
I think one of the example problems on the homework was like what we let me think of one.
You think this stuff's gonna be on the exam, or not yet? Probably the next exam.
No. Next exam, yeah. I'm really bad at explaining it. Like
You're getting there.
I'm
following you a little bit. I've been catching up on another class, and I've kind of been slacking in here. So.
okay.
I had no idea we were getting into this, or I would have been putting a little more effort into it.
Yeah. Okay, so try and okay, so some of the examples on the homework, like some of the questions would be like 6 to the x power is equal to 216.
Uh-huh. 6 to the x power is equal to 216. So we're trying to solve for the x.
Solve for x.
So you'd have to take the log of 216 and divide it by the log of x.
No, the base number. Or like
Give me the question one more time. I'll write it down.
Okay. So 6 to the x power is equal to 216.
So you got 6 with the exponent is x.
Yeah.
216.
Solving for x.
So do you take the log of 216, or what's the?
Yeah, so like the inverse way you would write it would be like the log, and you take the number that has the exponent. So in this case, it'd be the 6. So you do the log of 6 parentheses, and then you take the other number, 216.
Divided by 216?
Well, like the way it would be written out would be like the log of 6 parentheses 216.
The log of 6 parentheses. Okay.
And then the way you would work it out is you would do the log of 216 divided by the log of 6.
So where'd you? Oh, okay. And that's how you're solving for x.
Yeah.
Okay.
Because like then like the whole like the log of 6 parentheses 216 is equal to x. So it's like the exponent hops on that side and switches it over here.
So, yeah, okay. I think I follow you now. So you got the log of
Okay.
216 to solve for that. The log of 216 divided by the log of 6.
Yeah.
And that's going to be x. X is 3.
Yes. And then, like, just to confirm, you can always plug it back into the original one. It's like 6 to the third power.
Should equal 216.
Yeah.
So when you write that out officially, it's the log of 216 6.
Other way around. So it's like the number that has the exponent is the base number.
I'll be log of 6.
Yeah.
Parenthesis 216.
Exactly.
Oh, okay. Oh, okay, I'm connecting now. Okay.
Awesome.
So how, when they don't give us, yeah, okay. See if I can apply this into the log of 432. So now looking at number 4, we don't have a constant. We just have x. So x is our constant.
Like the way that we work through it is first you want to get rid of that first log on the outside.
Mhm.
And basically to do that, you just kind of do the way in reverse. So it'd be like, so you would take the base number, and that's like the new number for the exponent, so it'd be like 4. And then you take the 0 because like that's going to become our new exponent.
So we just flip everything to the other side of the equation.
Kind of, yeah.
Okay.
4 to the 0 power, and then you just take the whole like log of 3, log of 2, and put it on the other side.
So it'd be log of 3, log of 2, x is equal to 4 to the 0 power.
No. You do 4 to the 0 power is equal to the log of 3,
Oh, okay.
parentheses, log of 2.
Okay. X, 2 parentheses.
And then like if you do 4 to the 0 power, it just becomes 1. Right? And then you just do it again, except this time you are using the log of 3 instead of the log of 4.
Be 3 to the 0 power. So when you write that out, is it 1 plus?
Well, that
1 plus 3 to the 0 power?
no. So it's like that 1 is on the other side of the equal sign now.
On the left or right?
So it's all by itself right now, like before we do the whole exponents thing. So the new equation we get is the log of 3, parentheses, log of 2, parentheses, x is equal to 1.
Oh, okay. I switched it around for some reason. Okay.
And then we just
So
do
when you
the same
switch
thing
4
again.
to 0 power, you just kind of do that all in one step. You just equals 1. Okay.
Yeah. And then you just do basically what we did last time. You take the base number of that first log.
So we got 3 to the 0 power.
No, you take what's all by itself, like what's on the other side of the equal sign.
The 1.
Yeah, and that becomes your new exponent.
To what?
To the 3.
Oh, so it becomes, oh. Okay, so
3 to the first power.
read the next line. What would it look like?
So after we did that, it would be 3 to the first power, or just plain 3, because that's what it would equal.
Right.
Would equal the log of 2, parentheses, x.
So 3 is equal to the log of 2, This is it. There's a reason why we lost the log of 1. Or wait, sorry.
There's no log of 1.
There's no log of 1. That's why.
Yeah.
Enough for fun, I guess.
Alrighty. And so you got that equation too, right?
3 equals the log of 2 and x in parentheses.
Yes. So, and now we just need to get rid of that log one more time.
Just get rid of the log of 2. So do you take? You take the 3 and 2 multiplied by each other?
No. So you take the base number of the log, which is 2, and then you raise it to the power of what's on the other side of the equal sign.
You take 3 to the 2. 3 to the second. 2 to the third?
Yeah, like you take the base number of the log, and that's the new main number. That's the coefficient.
Okay, or your new constant.
Yeah.
3 becomes your new exponent.
Yep, and that's just equal to x.
And that's the pattern there. Okay.
Yeah.
So it becomes 8. 8 is equal to x.
8 is equal to x.
Well, that's not too bad. Okay. It's just kind of seems counterintuitive for some reason, but
yeah, it was just like that one was tricky just because it's like you have to do it like 3 times in a row. And yeah.
So your log base becomes your new exponent, and your old exponent becomes your new power. Okay.
Yeah. Yeah. So if you had like the
4 became my 4 to the 1 power, or 4 to the 0.
Yeah.
And because 0 was my old exponent, okay. And then 3 became my new exponent to the 1 power.
Yes.
Okay, I follow you. Thank you.
Awesome. Yeah, no problem. Rachel, did you work through the other 2 problems, or were you just waiting for us?
No, I worked through the other 2.
What did you get?
For B, I got 3.5, and for C, I got 3.58.
Was the second one rounded?
A little bit, 3.585.
Well, it's because like the thing that throws me off about C is she says find exact solutions. So it's like
Right. Yeah, how far out does she want us to go with?
exactly like
That's my point.
when I worked it out, like I didn't even log, like I just left it as like the log of 4 to the 9th plus 2.
Oh,
Just because like
gotcha.
that's as perfect as you can get it, right?
Right, yeah.
And like I don't know if that's the right answer, or it's like I don't know what she means by find exact solutions.
Yeah. I'm not sure on that one.
So are you able just to punch those in right into a calculator to solve them?
Yeah.
Basically.
What's
Like-
the formula on that one?
So for B, like you would just kind of this is like you're changing it to a log. So like the exponent, like the one that
X
like
minus
the
2?
4.
Mhm.
Well, you take the 4, and that becomes your new base.
Okay.
And then you take
On
the
the 4.
exponent. Yeah, and then like the number on the other side of the equal sign becomes what's in parentheses.
Parentheses 8. Uh-huh.
And then you would just move like to the other side, so it just becomes x
Equals
minus.
X minus 2. Mhm.
Yeah, and then you just solve it out.
So when you take the 2 to the other side, does it not affect the 8 in parentheses?
No. So
It
the
stays,
first
it
thing,
stands on.
if you were working it out, first you would do like the whole log of 8 divided by the log of 4, and you would get 3 over 2, or 1.5
Yep.
plus the 2.
Okay.
Yeah. Yeah.
Perfect. So what's the difference between that and C? Just 8 and 9?
Yeah, but it's like the thing about 9 is it's not gonna
Square.
evenly.
Okay. So it'll leave
So-
some crazy decimal or whatever.
But yeah, but you do the same
Same steps.
steps.
Well, that's easy enough.
Yeah.
So log of 4, 9 equals X minus 2. So do you always do the larger number for your first log? Or the one in parentheses anyway?
It's not always necessarily the biggest number. It's what's on the other side of the equal sign.
Okay. So that's your first log.
Yeah.
And then your second log is always the base.
Yeah. It's always the base.
Yeah, so 1.5849. She probably wants you to write that whole decimal, huh?
Yeah, I'm not sure how far she wants us to write out on that one.
Yeah.
Just be obnoxious and write the whole thing. That would be an exact solution for sure.
Oh yeah.
So what are they using these logs for? Is this just tie back into graphing?
They use logs to, like, if x is in the exponent,
Mm-hmm.
it's like it's just showing us how we can still solve it, even though
Can't
it's up
figure
there.
Oh, okay.
Yeah. Alrighty.
Thanks, guys.
Yep.
No problem. Good work, everyone.
Yep. We'll see you guys
Monday.
Monday at 11, right?
Yeah.
Good luck on your
All right.
exams.
Yeah. You guys.
Yeah. Have a good weekend.
Yep. See you guys.